If your electronics devices use one of these, then likely inside the device, there's something like one of these, or their tiny little brethren, to ensure a stable voltage is provided to the circuit. Hello, I am the Mighty Pez. In this video, I will demonstrate the differences between two device types for producing a specific stable voltage from a higher voltage input: a time-tested 7800 series regulator and a modern switching regulator. So please, join me. We have two different types of devices here. The 7800 series voltage regulator. These are pretty standard devices made by quite a few different manufacturers, and they've been around forever. These devices are DC to DC voltage converters. They perform exactly the same function. They take an input somewhere around 30 volts or less and convert it down to a desired voltage. In this case, these are all 5-volt devices. So they'll take a higher input voltage from a power supply, such as one of these Sinclair ZX81 power supplies, which is rated to output 9 volts, and it will convert it down for 5 volts for the ICs in your retro computer or whatever device needs to be powered by less than the input voltage. Now, these two devices function quite a bit differently. These original 7800 series devices function by converting the excess voltage to heat. So your 9 to 12 volt input, or whatever voltage, will result in excess heat being generated, which is generally not very good for devices, which is why on your ZX PCB you'll find that there's a heat sink to have this extra heat brought away from the board. However, the heat sink and the device are still inside a case. So the regulator will produce quite a bit of heat inside the case, even with this heat sink bringing the heat away from the PCB itself, which is generally not good. So modern devices can leverage one of these voltage regulators, which produce the output voltage in a different manner. It's actually a high-speed switch, and it will turn the input current on and off very quickly, whatever ratio is needed to generate the desired output voltage. Again, in all cases, these devices are the 5-volt versions and will take whatever input and generate 5 volts output. So I'll be demonstrating this. To demonstrate how this works, we're going to take the output of this 9-volt power supply, 9.75 volt power supply, and we're going to run it through a little test circuit. All the circuit does, we have a resistor for load that will generate about a 0.5 amp of load onto the voltage regulator. We're going to connect up the power supply and look at the input voltage. And despite the fact it is supposed to be a 9.75 volt power supply, even under load, it's producing 12.25 volts right now, which is kind of surprising. I do realize that many old power supplies will produce high DC voltage until placed under load, but I assumed once we placed the circuit under load that it would have reduced the output to somewhere around the 9 volts. But anyway, we're pulling a 12 volt input. So now I'm going to move the multimeter over to measure the output voltage. All right. We have moved our test over to the output of the voltage regulator. Let's plug the power supply back in. And now you can see we are in fact pulling 5.07 volts. So the regulator is doing what it's supposed to be doing. And I'll do a test in a moment to show how it takes the input voltage, converts the unwanted voltage to heat, and then produces the 5-volt output. But until then, we're going to go ahead and swap out a couple of these just to show that they all do the same thing. That one produces slightly less than 5 volts. So even though they're all identical part numbers, they are different brand manufacturers and might have different internal. That one also is 5.01. So these produce about the same. This device here is actually from an original ZX81, so this is the oldest 7800 device. The other two are pretty recent. So let's go ahead and look at the DC to DC voltage converters. So these are plug compatible. You can replace one of the 7800s just by plugging in a DC-DC. You can see that it produces almost exactly 5 volts. So this is a very, very precise device. And of course, it is my more expensive DC to DC converter. I'll try this one here. .92 volts, so slightly less than 5 volts. Again, different manufacturer, but well within tolerances. We're going to show a quick example of how these devices differ. So we've set our multimeter to measure current. Let's go ahead and try one of the 7800 series devices. And you can see we're pulling a 0.5 amp of current. Each one of the 7800 series devices, well, that got hot already, will show about the same current. Now, let's go ahead and show one of the switching voltage regulators. And you can see the current draw is much less. That's because the multimeter is averaging the current draw that it's seeing. And because the switching regulator is turning the current draw on and off in order to feed a constant current to the output, but at a reduced voltage, it's much more efficient. And hence, it will not generate near as much heat. I'll try this other voltage regulator as well, and we should see about the same thing. So now I'll go ahead and do a heat test. We'll go ahead and take one of the 7800 series devices. Take my handy Friga thermometer. It is a data logging thermometer. We'll start up the logger and we will plug it in. It's been 15 minutes and it's time to end our experiment. Looks like right now the probe is reading 87.4 degrees. We're also going to shoot it with the infrared thermometer, which is showing about 87 degrees. So fairly close. And we're going to use this as a comparison for our next test. We have now hooked up one of our two DC to DC converters. We've let the probe again stabilize, and we're going to apply voltage. This time we'll turn our multimeter to DC before we start. So again, we're pulling almost 5 volts DC perfectly. The thermometer is recording, and we're going to let it run for about 10 to 15 minutes. Here is the result of our test. The top curve is the temperature of the 7800 regulator in Fahrenheit over time. The second curve is the same load going through the switching regulator. Note that this test was performed at 500 milliamps. At higher current draws, the temperature waste product will be commensurately higher. I have measured over 200 degrees Fahrenheit at the 5-minute mark during previous high load testing. Although 8 degrees is not tremendous, it is but one of several components generating heat within an electronic circuit. A quick summary comparison. The 7800 series linear regulator is relatively cheap in comparison. I can purchase them in low quantity for less than $1. They are everywhere, having been around for many decades and produced by many manufacturers. They are low noise and often used where electronic noise is detrimental, such as audio applications. However, they are inefficient as they produce waste heat as byproducts. The switching regulator is much more efficient. However, it is relatively expensive, with single part costs being several dollars. Lastly, the property of high-speed switching can lead to electronic noise. Lastly, I will leave you with a couple of specs from the datasheet. I share this only to remind everyone to always review the datasheet for your specific component and your specific application. Thank you. I hope you enjoyed the video.